In this example, we're going to calculate a scatter plot and the correlation coefficient for two quantitative variables. A computer manager needs to know how efficiency of her new computer program depends on the size of incoming data. Efficiency will be measured by the number of processed requests per hour. And so the response variable here is the number of processed requests, y, and the explanatory variable is the size of the data. This is going to be called x. So applying the programs to the data sets of the different sizes, she gets the following results where data size is in gigabytes, that's x, and the process request is y here. So we want to first create a scatter plot, but first we need to run in the data, and we can do that by just running this in. So we have x and y. And the next thing we want to do is plot the data. So we can do this using the command plot, type in x as our explanatory variable and y as our response variable, and run this line. And we get a scatter plot, just very basic, of the gigabyte size and the number of requests. It looks like there is a moderately strong negative relationship between the two. And if we want to really quantify this relationship, then we can do the correlation coefficient. And this can be calculated in R by doing the command cor, so C-O-R. And it doesn't actually matter which order you put x and y in, but if we put x and y and just in the same format as we did the plot, it makes sense, and we get a negative correlation coefficient of negative 0.925. And so this makes sense because our slope is negative for our relationship, and so that should match the correlation sign as well. It looks like there's a moderately strong relationship in the scatter plot, which is true for the correlation too. We can see that the correlation matches what we see in the plot. All right, so if we wanted to add just a little bit of flair to our plot because it doesn't have any titles or anything, we can go back to plot and put in a main title. So here we can put in size of data versus requests. And that could be our main title. We can give a horizontal axis title. So instead of this just saying X, we can say X lab. So X label is equal to maybe gigabytes. We can give a Y label. So Y label is equal to processed requests. And we can also change the character. So if we don't like this little bubble, we can change it to something else. That can be changed with PCH. So PCH is equal to something else. You can change it. I like the 16-point character. It's just a solid dot. But you can change it to some other number and check out to see what those are. You can add a color to this. Perhaps maybe you want these to be green or something else. You can add the color, and we can run this new plot. We can see that we have size of data versus requests. We could put a more descriptive title in if we wanted to. We have green dots, green points. Gigabytes is our label for our explanatory variable, and process request is the label for our response variable. And so I don't really like that green color, so I might come back here and change that to blue, and it looks a little bit better that way. All right, so this is how we can calculate the correlation, talk about the relationship between the two so we can quantify the relationship, and then we can really see that relationship in the plot. So there is a moderately strong negative linear relationship between the size of the file or the data and the number of processed requests.